Oh, you're speaking.
All right. Let me start sharing here. So, can you see my screen?
Yeah, no.
Okay. So, I'm going to talk about Docker, what it is, what it's used for, why so many people deploy their applications to Docker these days. Um, and about me, I'm a senior backend engineer at Big Nerd Ranch, which is a software development company. They also do training and boot camps and things like that, based in Atlanta.
Are you in Georgia?
No, I work remotely for them.
Oh, okay.
So, yeah. And I'm also a Z Shell plugin developer and stuff like that. So, I have some presentation styles which are listed here. Usually, I try to bold commands that you would run in the command line, things like that. So, Docker, the main purpose of Docker is to containerize your applications, which means you're isolating applications from each other, from the host, from the underlying operating system. And by doing that, you make your deployments much more scriptable, reproducible, faster, and simpler. For example, whenever I'm asked to deploy something, the first thing I do is go and search and see if I can find a Docker container for it, because it just makes things so much easier. And orchestration is also made easier with Docker, and orchestration is just the process of basically automating deployments and maintaining your application. And Docker allows that. And Docker is actually just one out of many container systems, and it's built on other technologies that already existed in the Linux kernel. So the main draw of Docker is that really it makes things a lot easier for the user. It's kind of like a porcelain, like what Git calls porcelain commands. It's just a nice interface to container technology, basically. There's other technologies like Kubernetes, which are built on top of Docker or other container systems, actually, and allows you to run a bunch of containers in parallel, for example, and load balance between them. And also, Kubernetes, whenever a container dies, it will restart. It will create a new container and run that. So basically makes your containers resilient. And each container is really, you could think of it as a mini virtual machine. And it has its own file system, processes, etc. So it's kind of like, it's its own computer. But the difference between a virtual machine and a container is much, much, much lighter weight than a virtual machine, which means it requires less disk space, less RAM, less CPU overhead, etc. And so that's one of the big advantages of containers over virtual machines, is that there's so much more lighter weight that for deployment of application, in most cases, the container is a better option. In fact, right now I'm working for a client of Big Nerd Ranch, and they're deploying their application in virtual machines in AWS. And because they're doing that, it makes deployments much slower, unfortunately. And it also costs more money because they're requiring more memory, CPU, and disk space to reproduce a lot of things in this virtual machine that are not necessary for the application. So that's kind of like an anti-pattern, basically. The questions?
I have a question.
Yeah.
Maybe I misunderstood what you said, but you said a container is lighter than a VM. So is it a VM or is it not a VM?
It's not a VM. It's a similar concept where you have a virtualized like computer kind of or server. But if you say the word VM, you're specifically referring to a full-blown virtual machine where everything is virtualized, including the kernel and all the hardware and all that stuff. Containers are not VMs. They're similar. They're virtual, but they actually share the kernel and other processes with the underlying host. So if you say container, you should definitely not say VM.
Gotcha.
Because they're big. That's a huge distinction.
So
But
let's
they're
say
both virtual.
like a database container, and maybe it's built on Linux, some Debian distribution.
Yeah,
But you're running that on a Mac host.
right.
Is that using the underlying
Mac
host?
kernel. Yeah.
Okay.
Yeah, it is. Yeah, so a container only virtualizes some aspects of the computer or server or whatever host, whereas a virtual machine is a full-blown emulation of every aspect, and so that requires a lot more, CPU, RAM, disk space, etc. So, yeah. So that's kind of an overview of Docker. It's just a container technology among many others that allows you to run basically little virtual computers kind of. I can rephrase this to say that it's not a VM, but it's similar. So Docker is a popular container system. When you say Docker, it's not clear if you're referring to the client or the server / daemon, right? So you have to kind of say, I'm talking about the Docker client or I'm talking about the Docker daemon or server. And so the server has to be running in order for the client to work correctly, right? And you can have different clients which are connecting to servers that are either on your local computer, local host, or it could be on some other remote server or daemon, right? So those are distinct in its standard client server architecture, right? So if you talk about an image, that means it's a blueprint for a container. If you talk about a container, that means it's a running instance of the image. And so you can have multiple containers for any image, right? So they're basically distinct deployments of some blueprint. The image tag refers to the image version. So it's like versioning for a particular image. And if you don't specify the tag, then it defaults to latest tag, which just means the latest version, though that's merely convention. Another term is registry, and a registry is like a Git repository. It's a way to store Docker images, basically. Docker Hub is the most popular remote image registry, sorry. And so whenever you are by default running Docker commands and you're pulling down images, you're using Docker Hub. So we can go to Docker Hub and let me go here with Firefox browser. So Docker Hub, you can browse for various images.
Like Postgres.
And yeah, there's tons of different images. So what you'll see is that a lot of times people namespace their images behind the organization. So like Ubuntu / Nginx, right? So, there's a lot of different Nginx images out there. So yeah, Postgres, I mean, there's Docker images for almost anything you could possibly think of. And actually, it's very easy to create your own images, in fact. And a lot of organizations do that, create their own images and store them on their own registries. Now, whenever you type the command docker login, that's going to be used to authenticate to Docker Hub by default. And you need to do that in order to push a Docker image to Docker Hub or to pull from a private registry, like your own registry, if you had some private images. Now, if you're pulling public images, then you don't have to log in, right? So if I'm over here and I run Docker container run, let me just simplify this. Docker container run -i -t nginx. What that is going to do is pull down the nginx image from Docker Hub and then going to create a container out of that image and then run that, run that container. So that's what I did right there. I had already downloaded the image in my cache, so it didn't re-download the image, but I just created a container. And if I do Docker PS, so let me take a step back. So there are several different Docker servers or daemons, right? So there's Docker. Where am I going to talk about it? Oh yeah, here. So on Windows or Mac OS, you can use Docker Desktop application. Some people use that, some people don't. Their licensing changed, so a lot of people are moving to other solutions. What I'm going to use is Podman. So Podman is another solution to a Docker server. And so I installed Podman with Homebrew. Then I do Podman machine start. Okay. And then that starts up my Docker server. And then I need to export this environment variable. I'm going to put that here. Anywhere where I want to access the Docker daemon, I'm going to export that environment variable. So if I run this nginx container, I do Docker PS up here, and see that I have a container ID, the image that I used, the tag, the command that was used to start, that was started when the container was created, when it was created, status, a random name. And yeah, so you can see I have a running container right now on my local Docker daemon. So yeah, I'm going to be using Podman for this presentation, but you could also use Docker Desktop, and other daemons. So yeah, so a lot of enterprises create their own Docker registries. And for a lot of the enterprises I've worked for, they use JFrog Artifactory to store their Docker images. So they have an custom application. They want to deploy it. They create a Docker image out of it. And then they push the image to JFrog Artifactory. And then in Kubernetes, they go and pull down the Docker image and create a container out of it. And that's the deployment process. There's another platform called OpenShift Container Platform, OCP, which is basically Kubernetes with some other stuff on top, and it has its own internal registry for building images in a build pod and deploying containers in the pods. It's Kubernetes terminology. But basically what I'm saying is that you can have registries in a lot of different locations. So yeah. Now, whenever you run a Docker client command, you have to have the Docker daemon running somewhere, right? And so if you see cannot connect to the Docker daemon, well, that's because it's, it's a server, right? You have to start the server before the client will work. So, another questions?
Yeah, I think I usually check on the server by using Docker or brew services list to see the service.
Yeah. So brew services in Homebrew, they have the concept of services, which are things that are going to be running, like server programs that would be running, for example, when you log in or things like that. And so I'm not sure if they have a Podman service, but if they did, you could just say brew services, like start Podman, and it would start whenever you logged in and stuff like that. So I don't have a Podman service, so I'm just starting it manually with the Podman machine start. It's the command I'm running to start up Podman. Well, you could create your own service there, to have it start automatically, and you could, like export this locally in your, shell configuration and stuff like that. So, yeah. So Docker aliases. So there's a lot of different Docker subcommands, right? Subcommand means that there's a command after the main command. The main command is Docker, then the subcommand would be attach or run, etc. And they keep on adding all these aliases because I guess it makes things shorter. So instead of saying Docker container attach, you could say Docker attach. Instead of saying Docker container run, you could say Docker run. So there's a lot of different aliases out there, and you can use them if you want. It just makes things a little bit simpler. So you can see, though, with the Docker container commands, right, subcommands, the following, so like the second subcommand, that modifies the behavior that you are doing to a particular container, to a running container. And then the Docker image subcommand, you can see all the further subcommands. Those are, modifying the images that you have in your cache, your local cache. So that's important distinction is, are you referring to an image or a container? So what I demonstrated was I did Docker container run over here. I could have also done Docker run, right? Because of that alias, essentially. So whenever you see that, you know that there's multiple ways to do the same thing. There's a lot of different Docker images. One of a well-known one is Alpine, which is just a very simple Linux distribution, very lightweight. It's a very convenient starting image for a lot of other Docker images. And yeah, and that's really all there is here. So I'm going to talk a little bit about Docker files and what they look like. And you can build a Docker file. In fact, you do, off of other Docker images as starting points. So that's very convenient because you can take somebody else's Docker image, add a few modifications, and then create your own, a new derived image. So now I'm going to talk about some Docker subcommands that are very frequently used. So Docker pull image, that's simply pulling a Docker image into your local cache. By default, it's going to use Docker Hub as the registry. So if I do Docker pull Postgres, that is going to simply download this Docker image into my local cache. And that's useful because then I can just create as many containers out of that image as I want. Docker run Postgres, right? So this message here is saying that I have to add environment variables before I run this image, as a container, which I'm going to talk about later. So you can also pull down an image at a particular tag, right? By default, you're going to be using the latest tag, but you could search for another tag, different version essentially. And say you wanted to pull from a custom registry, so that you would just say Docker pull, the registry URL, and then the port, and then slash the image, and then colon the tag optionally. So that's just showing that you don't have to use Docker Hub. You can use any registry actually. And Docker run image, actually, that pulls down the image before it runs the image, obviously. So obviously that's kind of a shortcut. You don't have to manually pull the image unless you want to, So you can see here when I said Docker run Ubuntu /nginx, says can't find the image locally in the cache. So I'm going to go download the image. And you'll notice that a lot of these Docker images have layers. You'll see these basically hash code, and that's like it's just showing you that, for example, there was 5 parts to this image that got downloaded. And that's useful just because some of these layers can be reused between different images, so it speeds up, downloading images. Now, if you type Docker images, I'll type it over here. It's going to list all your different images that you have in your local cache, and shows you the image ID, size, when you created it.
Now this is asking Podman
Yeah.
your images are because you exported the variable.
Yeah. So I exported this environment variable called Docker host. And so now I'm communicating with the Podman daemon. Yeah.
Cool.
So I could have another daemon running, for example, Docker desktop, and I could have them both running. I'm not sure with the ports. You'd have to make sure that there's no port conflict. Looks like here it's just using a Unix socket. So you could have multiple daemons running and communicating with them independently. All right. But yeah, right now I'm just communicating with Podman daemon.
So
And
spin up a container of an image. Because it looks like you have multiple images within that image, and it's spinning up. Is that all part of the same container, or is that like individual containers that get started for that?
You never really, whenever you start up a container, it's only one container. Which image are you referring to?
No, I just see like on the bottom, like you have different hashes that says download complete.
Oh, those are just layers. They're not, those layers are just shared between containers, or images rather.
Okay.
And they're not independent containers, or images. It's just layers. Docker has a concept of layers that it uses to kind of represent like that binary image in different parts. You can read more about it, but it's not something you could run.
Gotcha. It looks like it's just different images that it's downloading. Like those get used in.
Yeah, it's like it's not images. Well, if you say image, then you're thinking about like a blueprint for a container. If you're talking about a layer, now it's more of like parts of an image which could be shared between different images. Yeah, it's layers are used to avoid transferring redundant information, skip build steps. Each instruction results in a layer. It's below the concept of an image. Well, it says each layer is the image itself. Well, it's not something you would run basically directly. I don't know if that makes sense.
It's kind of like how Homebrew uses a bunch of packages, and some of them are leaves, which are things you can run, but some of those leaves rely on other packages. You're saying that a Docker image has many layers that are not like executables in themselves.
Yeah. Yeah, you couldn't directly address these layers, like you couldn't run the layer. You get what I'm saying? Like not directly. Yeah. So you can also delete images. You can do Docker RMI to delete an image. So, say I downloaded an image and I don't need it anymore, like Postgres. So in this case, it aired out because there's a container that is using the Postgres image. If I do Docker PS, it's going to show me all the running containers. You'll notice here that the Postgres container is not running. All I have running is the Ubuntu Nginx container. So if I do Docker PS-A, that's going to show me all the containers that have ran in the past, but are either currently running, as in status is up, or they've been exited. So they're not running, but you could start them up again, for example. So in this case, I can't delete the Postgres image because there's a container. It's not running, but it's still there. And so I'd have to go and delete all of the containers referring to that image, even if they're stopped, basically. So that's what's happening there. So you can force remove an image, even if there's a stop container that's based on that image. So that's something that you can do. Docker RMI-F, so I can show that. Docker RMI-F Postgres. Now that just means that whenever if I do Docker run Postgres, now I got to go re-download that image to my local cache, right? And then create a container out of that image. That's what's going to happen if I run that. So whenever you refer to a Docker image, you could refer to the image ID or the name. So in fact, I could have done Docker RMI and then put in my ID here instead of Postgres. I typed Postgres because that was the name of the image, but I could have put in this unique ID that is listed in the leftmost column here. Not for the containers, for the images. I can put in an image ID to refer to any given image, or I can put in the image name. Right, so that's the image. Every Docker image has a unique ID, and you can refer to that image with that ID. And it's the same thing for containers. They have a unique ID that you can refer to them, or they have this randomly generated name, which you can use to refer to them. And I don't really the unique name here on the rightmost column, that's kind of just some random name. It's much better to use a custom name for your Docker containers as opposed to using the random names. So I definitely recommend that. I can show how to do that later. So Docker subcommand is used. The Docker run subcommand is used to create a container out of an image. So if I do Docker run -it Alpine, -I means interactive and -t means basically make it work with the terminal. And so didn't find the image locally. So it's going to go download it from Docker Hub because that's the default registry. And it's going to create a container out of that image and then run the entry point commands in that image, which is basically just a shell. I believe it's probably SH, born shell. So yeah, that's all Alpine is doing because it's not designed to run an application. It's more of a starting point for other containers or images rather. So Docker run -it Alpine :latest. It's the same, but uses the latest tag explicitly. I could run the Alpine image at a specific tag if I wanted to. I can also run a container out of an image and then delete it right after I have exited. So I can do Docker run -rm -it Alpine. And that's could be useful. Now, what's really useful is this -e option to Docker run. And that allows you to set environment variables in the container. And that's actually something I'm always doing. For example, I could do Docker container run -e columns is equal to my current columns in the terminal, lines is equal to my current lines in the rows in the terminal, and then I run the Alpine image. So -e allows you to set any arbitrary environment variable in that running container. And as I showed earlier, whenever I was trying to run Docker container run on that Postgres image, and I try to, start a container out of the Postgres image, it actually, see, I deleted the image, so now it's got to re-download the image. This container is saying to me that it has to have this Postgres password environment variable set in order for the container to basically be able to start its entry point. So I can do that. -e Postgres password and some random password. And now I have a Postgres container running. So Postgres is a SQL database, and it's running on my local Podman daemon. And it is also currently not accessible. And it is not accessible because I have not done any port forwarding. So you can see here it's saying listening on IPv4 address 000, and that means it accepts connections from any host, and it's running on port 5432. But I cannot access it from my laptop because I have not done port forwarding. So that just shows you that by default, Docker is going to completely isolate your containers, right? So they're not accessible by default from any other container or from any other server or computer or client, right? Outside of, my network, for example. So a lot of people there's I've seen a lot of confusion on how they want to be able to communicate between Docker containers, and by default that's not possible. You have to run specific commands to enable that. Any questions?
No, we're good.
Okay, so port forwarding, that enables you to access a container from outside of the container. So if I do Docker run, I'm going to stop that container. Docker run -p 8080. This is the external port. and colon, then the internal port, and then I do nginx. Now what I just did is I enabled access to the container, to the container's port 80 from my local port 8080. So now if I go to localhost 8080, now I just accessed my container, right? So clearly I put 8080 here, so that matches up with 8080 right there. So if I change this to 8081, I go here and I try localhost 8080, well, it's not going to work because there's nothing running on 8080. It's 8081, right? So you can change the external port to whatever you want. The internal port for the container matters because nginx is a HTTP web server, and that's the default port that it's going to be running on. So that has to stay 80. So yeah, port forwarding is required to access the container from outside the container. And that's the whole point of containers, is that they're isolating the application from other applications, right? Now, I talked about this, and that is, what if you want to communicate between containers? So say I have an nginx container running, like I do, and then I wanted to start the Alpine Linux container, okay? Oh, I need to do -it. So I have an Alpine Linux container running, and I have an nginx container running. Could I access my nginx container from within my Alpine container? The answer is no, you cannot. Because try to curl localhost. Oh, well, I don't even have curl installed, so let me something a little bit more fully featured. I'll use the Ubuntu image.
So
But
now you
yeah.
are running a virtual machine.
What?
So now you are running a virtual machine because you're running Ubuntu?
No, I'm not running any virtual machines.
Okay, it's still just an image that uses the Mac OS when needed.
So virtual machines are very different than containers. A virtual machine is a full-blown operating system. I need to change this to make it less confusing, but I'm not running any virtual machines. I'm solely running containers.
Okay.
And I'm using, instead of the Docker desktop server, I'm using Podman.
Yeah.
So Podman is an alternative Docker server or daemon, and it's a lot of people are using it nowadays because it has really open licensing and stuff like that. But it's a daemonless container engine, and I have actually this alias Docker to Postman or Podman, sorry. And so actually I'm running Podman commands, but it's all transparent because they have the same API basically for the client.
Okay. Yeah, I just saw the image Ubuntu and I just, operating system in my head, but I get the difference now.
Yeah, none of these are virtual machines. They're all containers. It's just a very lightweight image of an Ubuntu operating system. The minimal things that you would need. So I'm in Ubuntu. I do ls-l. I'm in the slash directory, right? So this is like the exact same type of thing you would see, the same directory structure you would see in any standard Linux computer, right?
Yeah.
So it's literally like I'm in some type of Linux computer, but actually I'm in some container.
Okay.
So I can run like a top command, and that's going to show me all the commands running in this little container. And right now there's nothing besides bash and top, right? So like this is you just think of it, you're on some random server, right? It's just that this is a container, so it's virtualized. And you'll see if I go into bin/bin, it has the standard commands you would expect, just less of them compared to, a virtual machine, for example. I can type yes, run the yes command, whatever. And I'm in a bash shell. So I have various environment variables, stuff like that. So I can also demonstrate how you can set environment variable hello testing. Now I type env and you'll see this environment variable was set here. Hello is equal to testing. All right, so it's just a container, a virtual type, virtualized operating system, right? Isolated from everything else by default. Does that make sense?
Yeah.
Yeah.
But we can't curl the 4041, right?
No, you cannot. Yeah, you cannot by default communicate between containers. So I have up here, I have an Nginx container, and it's running the Nginx web server, but I can't access that from Ubuntu container by default because everything's isolated. So up here, I have the port forwarding running, right, in my Nginx container. And so I can access the Nginx container from my Mac, but I still cannot access it from my Ubuntu container. Does that make sense?
Yeah.
So the port forwarding is distinct from the stuff I'm going to show next, which is the Docker networks. So the solution for communicating between containers is Docker networks. And so you create a network, and then whenever you want to have containers in that network, you have to specify with the --net option the network. And then all the containers that you start up with the --net option will be able to communicate between them. All right. So let me demonstrate that. So I'm going to run this command to stop this container. I'm going to run this container here, Nginx. So we change it. So I'm going to say Docker container run or Docker run. I'm going to give it a network --net. And then I'm going to put in my network name. I'm just going to call it network for now. The name of the container, which I actually need. I need a custom name for the container. Okay. And then I'm just going to run it interactively like that. All right.
So you're giving that network the name.
Yeah, actually, I need to create the network first. Sorry. So I create a network called network. You want me to call it something else?
No.
Test network or something?
Cool.
All right. I'll call it test network. Test -network. So I create a network. It returns a unique identifier for that network. Now I'm going to change this to test network. So I'm going to run a container in that test network. I'm going to give this particular container the name. Let's just call it something else. Container. Okay. So now I'm running this container in this test network. Now I'm going to run another container in that network. So I'm going to do that over here. I'm going to change the name to test network of the network, right? This is going to be the Alpine image. Okay.
Or the Ubuntu image.
No, I mean, I can use Ubuntu. You want me to use Ubuntu?
Yeah, it says curl.
Okay. So now I have two containers running in my network called test network. Okay. Now I'm going to run, I'm just going to use wget actually. So I'm going to say wget -q o and then dash. That just means whatever response, HTTP response I get, just print it out as opposed to going to a file. Okay, that's what the capital O and dash mean. And
Okay.
the Q for wget means be quiet. Don't show me all the like the downloading percentage. That makes sense.
Yeah,
This
so
is equivalent to curl. Okay.
you can -q -o with a
Yeah,
space.
and then dash.
Yeah.
Because I could put a file name like that,
Yeah.
but I'm saying dash because that represents standard output. Okay. And now I'm going to put in the name of my container up here. Nginx container. Okay.
Okay.
And what that's going to do is I'm going to make a request from my Ubuntu container into my Nginx container. Okay.
Yeah.
Oh, I don't have a wget command, so I could install it, but I know Alpine does. Wget. So wget -q. Oh, there's no.
No history, right?
What?
There would be no history because you're not in the same.
Right. Yeah. Yeah. So what I just did is I just made a request to the container named Nginx container, right?
Yeah.
How does
And-
Alpine know the name of the Nginx container from within?
How does it know about it?
Yeah, because you started Nginx container from the host.
Yeah.
It up there, but now you're in Alpine below. How does
Yeah.
it know about that name, that container?
It knows about that name because it's in the same network. Yeah, I ran it in the test network.
Docker has like an MDNS built in,
It's-
so container names know about other containers.
I see.
Now let me ask you this, Jacob. If you had specified a port as well on this, would the other element in the network have needed to use that same port? Would it have had to curl with localhost 8,000?
No, because that port forwarding is distinctly for
external.
Yeah. Let me give it
Like
Nginx container 2. No, we don't have curl. And I say container 2. Okay. Now
okay.
if I do it's -p, right, for the port.
Yeah.
Oh no, I'm sorry. You just do colon. Sorry.
Oh, for W.
I'm an idiot. Okay. Now I try 8081, right? Or 8080, sorry. That's not gonna work because that's for port forwarding from external. Right? So I can go here, localhost 8080, that works. But this is inside of a container. So it's not, the port forwarding is not doesn't apply. Okay, so I just use port 80, right?
Yeah.
Because I'm not outside of the container network. I'm inside the container network, so the port forwarding doesn't apply. So in this case, I have port 8080 forwarded to 80, so I can access the container from my MacBook on port 8080, sorry. And then I can access the container from this other container just on the default port, which is 80, right?
Okay. What about this? What about if if I'm running Nginx container and I'm connected to the network, and then I run another Nginx container on the same network, is it going to have a port conflict because something's
Yes.
already port?
Yes.
Okay.
Yes.
Cool.
Yep. It will have a port conflict if it's in the same network. Yeah. Because no, it won't. No, I'm sorry. Nope. It will not have a port conflict because you would access the container with a different name. So it's
Oh,
distinct. It's like different computers. Here, I'll demonstrate that. So let's create. First, I need to export that. We say Docker. Let's run another container. I'll change this port to 8081 for port forwarding. Still on the test network. Okay. So now,
why wouldn't you keep it at port 8080? Because then you'd have a conflict, right?
yeah, I would have a conflict on my local accessing it on localhost. Yeah.
Yeah.
But between the containers,
Okay, so if it wasn't doing port forwarding, you just changing the network name, you're saying would be, yeah, it makes sense.
now so I have two Nginx containers running. So I can access one with 8080, and I can access the other with 8081. And
Okay,
then
so-
inside this Alpine container, I can access either one by using the different names.
They don't take up the same ports because they're on different containers.
Yeah, they're different containers. So it doesn't matter if they're both running 80 on port 80 because they're different containers. They're completely isolated.
Okay. I got you.
Yeah. That's what I'm doing. I'm inside this Alpine container and I'm accessing the other two containers independently. So you can see over here in these tmux panes, I make a request to container 2. That's showing up here in the Nginx logs. I make a request to container 3. It's showing down here. And these,
Cool.
see?
Yeah.
So that's showing you I have 3 containers in the same network and I'm able to communicate between them.
Cool.
So that's Docker networks. That's the recommended way to enable communication between containers.
Okay.
So I also didn't demonstrate this, and that is that whenever you say Docker run, and then after the image name, you can put a command here, and that will override the default command that's being run. So when the container starts, so I could say pwd, for example, and that's going to just show me that it started up container, it ran the pwd command, it showed me slash because that's where it was in the file system, and then it exited. So you can run any arbitrary command that you want after the image name, right? And there's specific commands in the Docker file that enable that to be overridden. Sometimes there are certain images that don't allow that command to be overridden. In fact, in those images, you're just passing arguments to the command that's used to start up the container. That's probably confusing because you need to see what a Docker file looks like. So in this, I'm skipping a little bit, but a Docker file basically has instructions for creating a container, right? Well, actually, it's instructions for creating an image, which you then create a container out of. But there's this instruction called cmd command, and that's the entry point command that gets executed with Docker run. And there's also another instruction called entry point, and I can't remember. Oh yeah, here it is. So you can either use entry point or cmd in your Docker file, and the difference is whenever you pass an argument after the image name for command, it replaces the the CMD, whatever you have in CMD with your argument. So that's what's happening right here, is that in their Docker file for Alpine, they have this entry point, and they have CMD directive, and it's saying like sh or something, and I'm replacing that with whatever command I want to run. Does that make sense?
Yeah.
And if they had used entry point instead of CMD in their Docker file, then I would be passing arguments to their entry point. So you need to know on the particular image that you're looking at whether they're using CMD or entry point to figure out what's going to happen when you pass additional arguments.
Cool.
All right. So Docker networks. Now you can list the networks, Docker network LS. And you can see there's the test network that I created. It says it's a bridge network. Scope local network ID. You can remove the network by referring.
Created a named network, but by default, everything goes on the bridge network, right? So you could have done the exact same thing communicating between the containers as long as they were named.
I'm not sure. We can try it.
That's was my
I'm pretty
impression.
sure if you don't specify the network, I'm not sure if you can access.
So I don't know if anything's different between just straight Docker run and a Docker compose, but I do that all the time.
Okay.
I'm not making a custom network. I'm just talking to the machines with the names of containers.
We can try that. And then let's run. Fine.
Oh, so just assume they're on the same network?
By default, everything's on the bridge, unless you put it somewhere else. Because there's bridge and there's host. So host is you're talking directly to hardware. Bridge, you're talking to Docker.
That didn't work for me.
After the O?
I'm putting in the name of the. I ran an Nginx container with the custom name of Nginx2.
No, but after
Oh, it eggs. What?
don't you need a space? Don't you need a space after the O?
Your wget command is off, I think.
You
need a space after the O. No?
I don't think so. I see. I'm not able to access this Nginx2 container without some sort of network.
Interesting.
Yeah.
Put it on bridge. I guess it would be the same thing. It's creating a custom network.
Let me try. Bridge. I gotta give a different name. Okay. Now, see if I create a specific name, I have to make sure that I create another unique name. So Nginx3. Let me try specifically putting it in bridge. Give it a unique name. X3. Oh, I don't seem to be able to. I have to
Cool.
give it a unique network, I guess.
All right. Well, thanks for trying. That was
Yeah.
must be happening automatically on my Docker Compose.
Yeah, I mean, Docker Compose is, another, I don't know if I talk about it here, but Docker Compose is another layer on top of Docker, which enables you to basically automate multiple containers in a deployment. So it's a kind of abstraction above Docker. which I use a lot. So Docker containers, usually whenever you start them and then you stop them, all the information, all the data that was in that container is gone. And that's the whole point of containers, is that they are temporary. They're not something that you would persist data in normally. So if you ran a database in a Docker container by default, whenever you stop the container, all that data in the database would go away, right? Docker volumes are used to enable persistent storage of data between containers. So you could start up a Postgres container that's using a volume, and you could create data in that container, and then you could shut down the container, and then you could create another container based off using that same volume, and it would still have that data, because it's essentially creating a persistent storage outside of the containers and reusing that. So you can create a volume, you say Docker volume create, then you put in the volume name, you can say Docker volume ls, etc. Docker volume rm, the volume name inspect, Docker volume inspect. And then, so to use the volume, you say -v, the option, and then you say the local directory. So that is to the directory on your local computer that you're going to mount into the container at this remote directory. So I can show that. So if I run this MongoDB container and I wanted to, let's just say do slash TMP is good. TMP slash, or let's just say Mongo D. And then I know Mongo doesn't use /data, whatever. But basically, I'm going to be using this directory /tmb/MongoD as my permanent storage location for the MongoDB container. And that, so basically /tmp/MongoD is going to be mounted into the container at /data. And I could use this persistent storage or volume between as many containers as I want, basically. That makes sense?
Yeah.
Mhm.
So if you want persistent storage, you can use Docker volumes. Docker container names. So I demonstrated this a little bit before, but by default, you get a unique random name. And you can see that in this rightmost column. Happy, blah, blah, loving, layman, whatever. And that name has to be unique. As I was demonstrating before, whenever I was trying to start up a container that had the same name as some other container, it was erroring out. You see here, creating container name, Alpine 2 is already used. So you have to have a unique name for every container. When I don't specify the name, now I get some random name, right? So in this case, I have some random name called Pool Vara Hamihira. So that name is just a unique name. It has no real meaning. And that name is used to refer to the container from outside of the container. So you can, for example, rerun a stopped container with that name, unique name. So let me call, I already have Alpine 2. That's, so if I say Docker ps-a, I will see where's my names column? Oh, it's over here. So Alpine 2 is over here. Let me just grep for it. Alpine 2. So I can refer to this. This is a stop container, okay? And I could start that container two ways. I either put in the name like that, or I could have used the container ID, which is in this leftmost column here, right over here. So Docker PS. Now you can see that Alpine 2 is up for 12 seconds because I just started it. So container name is used to target a container, right? So for example, could do Docker container exec, and that's going to allow me to run any arbitrary command. Then I'm going to put the container name, and then I'm going to type the command. Okay. So I'm running a command in the container that I'm targeting by its name called Alpine 2. So whenever you run a container, you can specify the name with the -- name option, right?
Yeah.
Has to be unique. You use it target containers, stop containers, start containers, exec into a container, etc. Whenever you do Docker PS, it lists only your running containers. Docker PS lists only your running containers. Docker PS-A lists all your containers, whether they're stopped or running, right? Exited or up or whatever status. Oh, and then actually, if you look in this column here, third column, you can see the command that's being run. So for Alpine, the Alpine image, you can see that its starting point, its entry point is /bin/sh. So whenever I do Docker container run Alpine, it's just running /bin/sh at the very beginning. Whenever the container is starting. So you can see for these Nginx image, these containers based off Nginx, it's starting up Nginx, with a particular command, and that command is specified in the Docker file. Questions?
So at a certain point, do you start cleaning out your containers?
Yeah, you can. You can clean out your container. You can do that. You can also remove your images and stuff like that. So there's a lot of, I think I talk about it later, but there's several different commands that are useful to clean up your caches. And
Sorry if I'm jumping ahead, but
no, it's fine. So yeah, you can, for example, remove all stopped containers like this. So you say docker rm-f.
Cool.
Do that. And then this is going to delete all of these stopped containers. Now I do docker ps-a. Done. Actually, it killed all my running containers as well. So
-f.
So my example is, say you're doing Rails development. And we're told to Docker run, app container and then Rails test, and just run everything through the container. But then that's starting a new container every single time, and you just end up at the end of the day with this giant stack of containers that are dead.
yeah. So then you would run it with a name. You'd create a named container, and then from there you can run do Docker container exec in that container. Like that's what I would do.
Okay, that's good that you said that, because I was thinking about it the other day. It was like, it seems like running Docker exec Rails test would be better than run, because you're always on the one container.
Yeah. So when you're doing Docker run, you can start it up in detach mode with the -d option.
Right.
And then once it's detached, you can just run any arbitrary command with Docker exec.
Okay, yeah, that's
Can't you attach to it too? Can't you attach to a detached container?
Yeah, there's a command Docker attach for attaching to a running container.
That's just
Yeah.
for standard, right? Does that take?
Yeah, that's if you wanna like, run interactive commands. But you could also just do Docker exec and then do bash or something like this.
right.
That's very similar to Docker container attach. So let's see. Docker container run, just do Alpine, and I'm going to run it in detach mode with -D.
So attach will just let us go in with whatever it's currently running, which in this case is .bin/bin/sh. Is that what you're saying?
What?
Like Alpine by default runs the /bin/sh, right?
Yeah.
So like when we attach to it, we're just getting to that point, right? Or does Docker attach let us do more than that?
Well, it mostly attaches the standard in and standard output of your current terminal to the container.
Okay.
It's the main thing it does, but so it sets up your standard in, standard out, and standard error to the running container. So that would mean if you're attaching to a container that's running like bash, you could type in commands, you could see the output because that would be standard in, standard out, and you could see the error. So it depends on what command the container is running, right?
And if we wanted to run a different command, we'd have to use the exact thing. Or
Yeah, so let me demonstrate. So Docker container run nginx, okay?
okay.
So actually, let me give it a name so I can target it easier. Test. Okay, so if I do Docker container exec, I pass in --name test. Okay. And then I'll give it some command like pwd. Oh. Why is that not working? You have to be careful where you're putting the options. Unknown flag. Oh, okay. I just put in the name like this. Yeah, so now I started an nginx container with the name test. And then I said Docker container exec test pwd or whatever commands. And I could do bash. Actually, that's not working because I'm not doing -it. So if you wanted to run so I'm running bash in the nginx container. If you want it to be interactive, you have to make sure to do the -it options, because otherwise you can see if I just do this, there's no standard output from the bash command.
Yeah.
It's not attaching like you would expect, but in this case with the -it options, now I'm running the bash command in this container that's running nginx as well, right? So I can go in here and say localhost, right? Because I'm inside this container, and I don't need to create a network because I'm inside the container, right? I'm not in some other container. I'm directly in this container. And you could also, let's see, Docker attach, and then I put in test. So this is just going to hook up my standard out, standard error, standard in to the container. In this case, it's running nginx. So I can't run commands because it's not an interactive command, right? So it totally depends on what is currently running in the container as far as what attach does.
Cool.
So if this was let's try this. Let's try running bash, or I mean Ubuntu. Oh,
I mean,
okay.
like a normal Rails Docker container would run the app.
Ubuntu.
So we
Now I
would
attach to test 4. So in this case, because the Ubuntu image is running bash or by default, whenever I do Docker container attach, now I can run arbitrary commands, right?
The running server.
Does that make sense?
Yep.
So attaches mostly to hook up, your standard in, standard out, standard error to the container. Whatever command it's running, you're just going to attach this terminal basically to.
But you can also attach just to kill it, right? Like if I wanted to
Yeah, you could.
bug and I wanted to attach in, I could then kill it from that new terminal.
Yeah. If I
Yeah.
press, so I have 2 tmux panes, I'm attached to the same container from 2 locations. I can press, I could type in exit from either one, and it's exit the container.
Shows
So-
on both. It's cool.
Yeah, because I'm attached to the
Yeah.
same container from 2 different locations.
Actually, I had
It's
a
like-
question about that. So instinctively, I would like control D to get out of it. Or
Yeah.
Control C or whatever. But then that kills the server. How do you get out of an attach without killing it?
Control
That's no Control D is just going to send to EOF, which is
Control Z would send it to the foreground, I think.
to the background. You mean?
How's that what you want
Would
to
that
do?
be the same thing as detach?
That feels like you would be backgrounding the session that's connected. You know what I mean?
Well, if Control C is killing,
Yeah,
So apparently there's a special key combination for that.
what do they say about Control Z?
Control DD.
So there's detach keys. See, normally what I would do is I would just close out this tmux pane.
Ah.
Yeah, but muscle memory dies hard, man.
Yeah. I would just close out of that tmux pane and that container will still be running.
Okay.
But now I need to do this export.
What's actually happening when you close out of the panes? You're killing that shell, right? But you're not actually sending the exit command to the.
Yeah, you're just closing your attached. I actually don't know. Actually. Yeah, but apparently there's a special key combination for doing that. All right, back to this. So the name is important and it has to be unique, all right? And so you can use that name for a whole bunch of things, for starting a stop container, for stopping the container that's running, for killing a container, for deleting a stop container, for showing the logs of a container, which is very similar to attach, but I don't think
Is down a command or is that a Docker compose command?
that's a Docker compose command.
Okay.
Yeah. So Docker attach, you can run a container in detach mode. So you say Docker container run -d, say nginx. Now I have a container that's running. I didn't attach to it, right? So it's detached, and I could specifically attach now to that container with Docker attach, and I can use their randomly generated name or the container ID like this.
Yeah.
And I just stopped it, but so you can run any container in attach or detach mode with the -d option that will detach and run the container basically in the background. And just trying to clean this up. So That's what the -D option is for. And then you can attach to the running container with Docker attach, or you can exec, or you can run any command in that detached container, right? So Docker container run, put in the container name. I'm sorry, Docker container exec, I put in the container name. So it's just using the random container name, and it's just going to run any arbitrary command inside of the container. So I just ran cat /etc/os/release, and that's showing that this container is based on Debian version 11.
Cool.
So yeah, as far as starting up Rails, you could start up Rails in a container in detach mode, and then you could just exec various commands
Run the test.
into the container if you wanted to. So that would be more efficient than starting and stopping containers constantly. But the whole thing about Docker is that it's lightweight, and so it's not a big deal to start and stop containers because they're so lightweight.
So about that, I don't know that the containers are the issue. Docker on Mac, we've had nothing but trouble with this. They're like left such a bad taste that we don't use Docker very often. Although I recently started using it on Linux, and it's a completely different experience. Now I noticed that you're using Docker on a Mac. Do you run into memory issues where like Docker just starts eating up everything?
I don't really run a lot of stuff on my local laptop. Most of the stuff that I'm running, I'm attaching to remote Docker daemons, to be honest. So,
And are you still running, like you're using Podman to interact with Docker, but you're still running the Docker engine, is that correct?
yeah, I'm running Podman is an alternative Docker daemon or server engine as opposed to Docker desktop.
Oh, so it completely replaced it.
Yeah.
Yeah, it's a complete replacement.
So I was running Docker desktop like 6 months ago, and I would sometimes have weird things where like all my stuff would go down. I'd have to spin it back.
Surgically removed Docker from it.
Yeah, I definitely recommend looking into Podman. It's a lot of, I learned about it when I was working for this large enterprise, and they were saying, oh, let's use Podman because licensing is better, blah, 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 blah.
I like the simplicity of it too.
Yeah.
The Docker desktop app was this huge thing that, you know.
Yeah, Podman doesn't require, all that type of GUI stuff. It's just very simple.
Speaking of Docker issues, I haven't had the memory issue that Matt mentioned, but I usually run on a Mac at work, and regularly we have to download updated images, and we use the Docker registry, but the network their network seems to be inconsistent. Sometimes I'll download and it'll be like take a super long time to download an image. Sometimes it'll just go instantly. Do you run into that at all?
Like what I said, I mostly like during my work experience, we're running custom registries, either on the on their local network or in various places like that. So we don't use the public Docker hub at all. So
Okay.
yeah, I mean, there's a lot of different ways you can improve performance, and one of them is just having like local registries on your local network and things of that nature. So you can cache a lot of things.
We run into it regularly. Like I download from there almost daily.
Do you run into the issue where you try to update a container and it says that its name is already in use?
Mm-hmm.
So let me ask that question then. Sorry if I'm messing up your presentation.
Q&A time.
and I can hold it till later if you want.
Yeah, I mean, go ahead.
Okay. So let's take Home Assistant, for example, because that's the one that I was doing. That periodically gets updated. You want to pull the updates to the image. But when it tries to run again, it says that the container name is already taken. How do you like refresh an image?
Well, hopefully they're using the tag. That's the main thing, is to use the tag to version their image. If they're not using a tag, then it can be problematic
Well, I mean,
because
it's like latest.
yeah, latest. It depends on the registry you're using, and because a lot of the registries, they cache the images. So I don't know what registry you're using.
So what should happen? Is that like as simple as you just shut the container down, and when you restart it, it would have looked for the newest image?
Yeah, hopefully what would happen is that you would, as long as you have deleted the image from your local cache, it will go and pull the image from whatever registry you have configured at that
So
particular tag.
So you have to delete the image for it to
Yeah.
try. Okay,
Yeah.
maybe that's what.
Yeah, so you would have to go in and say Docker image RM or Docker RMI, and then you would put in the image name.
That's what I ended up doing to solve it. I just didn't know if that was the appropriate thing.
You can't put like update image like Docker-U.
Not if it's the same tag. I mean, if it's the same tag, then it's going to use that same image, you know. But that's like the whole caching mechanism. So you would definitely need to remove the image if it's using the same tag. That's the problem with latest. That's why people say don't use latest, because there's a lot of caching issues and it's not clear which tag you're using, right? So latest is discouraged, especially in enterprise level. So it's highly recommended that you specifically use a version for all of your images, not latest.
Thank you.
Yeah, so we, in various jobs that I've had, that's the latest tag has really been a big problem. So the instructions were never use latest, always specifically create a version for your tag, a tag for your particular image. So it'd be very clear what version you were using of the image, and there would be no caching issues. So yeah. So a Docker file is the instructions for creating a Docker image, right? So a lot of people want to create their own Docker images for a whole variety of reasons. Usually they have some custom application that they want to deploy in some Docker container, so they need to create their own Docker file. And so whenever you have a Docker file, you build an image out of that Docker file. And the way you do that is you say Docker build -t option, and then you put in the namespace, which is actually optional, but definitely recommended. And then you put in the name of the image, and then you put the directory of the Docker file, which is usually dot, because that's where you'd be running the command. So if I was, for example, if I had a Docker file, I don't have one actually right here, but I would say, my organization maybe, and then my image name, and then I would put dot, that just stands for the location of the Docker file. Maybe the Docker file was in some other directory like /work/git/repo/ whatever. In that case, it's just going to search for the Docker file in this particular location. It's going to create a Docker image out of that Docker file and put it in your local cache, basically.
Yeah,
So
so that's full stuff that it needs, right?
yes, yeah. So I'm going to talk about what the base image means, but whenever you do that, if you had not already pulled this base image, which is the first instruction in the Docker file, is from, and that specifies the image that you're building your image out of, right? So it's the starting point. And so if you didn't already have this image pulled at this, this image at this particular tag, it's going to go and pull down that image. That would be the first step, right?
Yeah.
So whenever you do a Docker build, that only means that your image is in your local cache. So that means you can now do Docker container run with your image name, right? If you wanted to share this image or upload it, to some other registry so other people can use it, then you would do Docker push and then the name of your image. So namespace / image name. And then based on your registry settings, it's going to, push it to Docker Hub by default or to some other registry so that other people can pull down your image. So yeah, that's how you build and push a Docker image. And so a Docker file would look like this, hashes for comments. So the first instruction is going to be from, and this is going to be your base image at a particular tag, or it could be latest. You're not supposed to use latest tag, but whatever. If you leave off the tag, it's going to use latest. So I definitely recommend putting the tag in there. It's going to pull down that image, and then it's going to actually create a container out of that image, and it's going to start running. You can put in commands that you want to run during your Docker build. So a lot of people are putting in installing, various programs that they need, dependencies for their particular app. They put that in their Docker file with the run instruction. And then you can set the present working directory of the container with the workdir instruction. You can copy all your local files in your present working directory to your workdir, your working directory in the container. That's what this does. Copy dot is local, your local, and then the second dot is your, inside the container, right? You could put in any directories, right? And then we have another run instructions, just going to run this yarn install command. And then the final thing is the entry point for the container. So whenever you would do Docker container run, and the image name, this is what's going to start up, right? So in this case, they're running node, and they're running the source src/index.js. So this is clearly a node-based web server, right, in this Docker file.
So here they could have put entry point instead of CMD.
Yeah, so you have two choices. Oh, and then also they're exposing port 3000 in this container. So you could access the web server with port 3000.
Yeah.
So there's two options. There's CMD and there's entry point in your Docker file. And the difference is whenever you put arguments after the image name, if you have CMD like this, all the arguments are going to replace all of this. So you could replace node. So say you wanted to run this container, but you didn't want it to run node source/index.js, then you could put other arguments, and then that would replace node. But if you have entry point, on the other hand, you're always going to be running this, but any arguments that you add after the image name will be added as arguments to node.
Yeah.
Does that make sense?
Yeah.
So it all depends. Can you replace this command or can you not? So like when I was running Alpine Linux and I was putting in pwd, in this case, you can see I'm clearly replacing whatever their entry point is, which is bin/sh. That's their entry point. or
Yeah.
CMD, sorry. That's their CMD, right? Their CMD is bin/sh. Okay.
Yeah.
That's what they're running. And if I replace it, I don't know what just happened there. Whenever I replace it with some other command, right? That's what's happening. I'm overriding their CMD.
Yeah.
If they had entry point, I wouldn't be able to do that. I would just be passing all of this as arguments to their entry point, right? That's the difference.
Cool.
Yeah, and then some useful Docker commands. So you can remove all local images like this. You know, there's that whole image cache. So in the case where you needed to use a new Docker image of Home Assistant, but you had the old one in your cache and you were unfortunately, using the same tag like latest, you would have to remove that local image so that you could pull down the latest image. So you can do Docker RMI and then -f, and then you can run this command, which just lists all of the images in your local cache. I gotta do this again. This lists all the images by their image ID in the cache, local cache, and then you pass all of those as arguments to Docker RMI -f. And Docker RMI is just forcing removal of the image, regardless of whether there's containers running or stopped based on that image, right? So that's going to remove all your local images. And you can stop all your containers, your running containers like this, Docker kill, and then PSQ, that's just going to list all the containers with their IDs, right? Right now I just have one container running, and I do -q, and it just shows me the container ID here. And so I can just do Docker kill based on that container ID, and it's going to stop all running containers. In this case, there's only one container running, so that's only going to show me one container ID, but I could start another container. Now it's going to show me two container IDs. Okay, Docker ps-q, and then whenever I pass those to Docker kill, now it's going to stop all those running containers. And I can also, yeah.
So funny story. I was working on a system where we had this Docker file and we had everything kind of orchestrated, but no one would help with my understanding how Docker worked. And so if I had a bad install on the system, I would run all these commands, and I think we were doing something with volumes, or we were actually interacting with my local database in some way. But I ended up going one further, and I uninstalled Docker completely, and then I reinstalled Docker, and that didn't work. So then I ended up wiping my computer completely, and that worked. But if you wanted to go one step further, you could
probably had a caching issue. That's what it sounds like.
Well, I would the prune. I would run all the commands to
really
try to clean all that up, but there was definitely something about the system that I didn't understand, and no one would spend the time to show me what was going on.
Yeah, I run the prune a lot too. Jacob, does that clean up volumes too, or it gets past the tag?
I don't. I'm not sure if it cleans up volumes. I don't know, but I know you can specifically remove a volume with Docker volume RM.
Okay.
But I don't know with the prune if it does that or not.
Yeah,
I could try it. Let's see. So I have Docker.
Configures in containers.
volume ls,
Fresh ones.
Docker system prune. Up all, it will remove all stop containers, all networks. Dangling that volumes isn't listed here, so
Maybe like -v.
Yeah, I've seen another being a -v.
for what? Prune?
-v.
E?
Yeah.
Yeah.
Oh, okay. Yeah.
Ah,
So
Yeah,
in that case, it does include the volumes.
that's what I did wrong. That could have been it. I remember the project I did end up wiping my computer for because I didn't have a lot of stuff. I ended up like really updating their README to have all the little Docker learnings I learned along the way. It was very
Yeah,
frustrating.
so
Like
I
could
didn't know that. So if you use the Docker prune and you either use -v or -- volumes, right?
you did like --all. They have like an all command that would be like more extreme. Would
Yeah.
include volume.
It
What
says
would that-
remove all unused data, but I don't know if that includes volumes. I don't think it does.
Okay.
If you do AV, oh, wait, it doesn't know about -v. Capital V? I don't know. The -- volumes is working, but not -v.
Sometimes they'll build it with the -- volumes, but they won't build the shorthand single.
Yeah.
It's an implementation detail. Like the -v shorthand is a luxury. It's not like some like lazy library people don't actually build both.
Yeah. Yeah, I have a whole learning thing, and whenever I learn new commands, I put them in there so I can remember them.
Ah, cool.
Yeah, so Docker system prim's really useful. You can do Docker system df. That's gonna list your total disk space that's being used by images, containers, volumes, build cache. So that can be useful.
This tells us everything. Is that the idea?
It just it tells you all the disk usage. Yeah.
Can you do -- help here to see if there's any other commands we could potentially do?
-v for both. That would be useful.
Yeah. Cool. Yeah, that's helpful. It's like
Yeah.
having
Also Docker system info, which shows you a lot of stuff about your particular Docker server,
System.
stuff like that.
Yeah, it's spiderwebs and all kinds of.
And see, I just wiped my computer at the time.
Looking for more, man. It's the only way.
Yeah.
Sure.
I think I even wrote like a bash command called like Docker nuke that would try and do all these things. It did uninstall Docker completely.
Yeah, so I mean that's mostly all I have for the presentation. And in summary,
Next one, you got to do on Kubernetes.
yeah, Kubernetes, there's a lot to it. I actually didn't talk about Docker Compose on here, but
Yeah.
Docker Compose is really cool because it allows you to create a file which you can list all these different containers that you want to basically orchestrate.
Yeah.
And so you say Docker Compose up, and that's going to bring up all the containers listed in your configuration file. And then you can do Docker Compose down, and it brings down all
Well,
the.
it's funny. I was working with a guy who would do Docker Compose start, and he used to get mad at me when I would do Docker Compose down because it would bring everything down completely. And he would always make the issues, and I'd be like, "Did you try Docker Compose down?" Because if you actually bring it all the way down and bring it back up, it's different than if you stop it and start it. So that leaves it still running, but it's just not like turned off. There's some nuance to it. It doesn't do a full. It doesn't like uninstall and reinstall.
So I figured out the networking thing I mentioned earlier. So Docker
Yeah.
Compose automatically puts, unless you give it a specific network, it
Yeah.
start everything in the compose file under a named skid default network.
Ah.
Oh, okay.
So like if you run Docker compose, it's going to name everything based on the folder you're in. So you'll get
Oh,
like
okay.
folder name skid default as the base bridge network.
Is it skid?
Yeah.
Flat?
I have a good example. So I don't know if people have heard of Elk Stack, but Elk Stack is a really useful way of visualizing and aggregating and visualizing log files. So you can take log files from a bunch of different servers and aggregate them and shows you all these different graphs and stuff like that. Based on what it's parsing out of the log files, and there's tons of stuff you can do with it. This is a pretty good example of what you can do, searching through log files and stuff like that. And so in that case, there's 3 components to the Elk Stack. There's Elasticsearch, Logstash, and Kibana. And so this is a perfect example of when you would want to use a Docker Compose, because you can create containers out of each of these components, and you can start them all up on the same network. Here you can see they have a named network called Elk. So that means that the Docker containers can communicate between each other.
So
And-
Matt, and right here, you wouldn't need to specify the network at all?
Well, because I'm sure for this, they are using this in tandem with other things.
Okay,
So they would want it isolated.
okay.
Yeah, in this case, you can see they have a networks configuration section based on that name.
Yeah.
So this would be, obviously you would want to have a named network in this case, because it allows you to configure and target things much better than maybe using the default name. But yeah, anyway, so Docker Compose is another abstraction layer on top of Docker, which allows you to essentially orchestrate containers and do all those type porcelain commands that I was demonstrating, but putting all that configuration in the file. So for example, this is like the Docker container run -p option, right? So they're doing port forwarding. They're setting environment variables, which is like the -e option, right? They're setting the network here, which is like the --net option.
So
and all that
effectively
stuff.
here,
They've got
effectively,
volumes here.
effectively here, they're making their ports able to be contacted externally, and also their network to be able to contact it externally. Things can opt into that network.
The network is for communication between the containers. So you
Yeah.
need to be able to contact Elasticsearch, which is a NoSQL database, from the Kibana container. So you need a network for that.
So that's for talking to it from the outside.
Yeah, like I could have another Docker Compose that could opt into this.
Or anything, like any app that needs to talk to
Yeah.
Elasticsearch needs to use that port. Because that's like the normal Elasticsearch port.
Correct. Yeah, so these ports, this is for port forwarding, and the network is for communication between the containers, these containers. Does that make sense?
But also external containers, right? Like external containers could opt into the same network.
Yeah, any containers could get attached, if they're in the same network, could access these containers. Yeah.
Let's say you want to completely isolate, they wouldn't have to be on the network as long as they talk through those
Yeah.
ports.
Cool.
Yeah, so Docker
And you-
Compose is very useful for things like multi-container type deployments, like Elk Stack or Zabbix, for example. Zabbix is another one that I have that I forked, because Zabbix is a PHP, it's a LAMP stack type deployment, and you can have separate containers for the database and for the PHP, the Apache PHP server, and all that type of stuff. And so this this enables you to set up like a whole slew of things just with one command. Docker Compose up, boom, you start up all this stuff, and then go to localhost whatever, and there it is. So it's extremely useful. The advantage of Kubernetes versus Docker Compose, though, is that Docker Compose is specifically about basically one instance of your application. And the whole point of Kubernetes is that you have multiple instances of your application. So for example, say I had a Zabbix deployment and I wanted 5 of them to load balance between them and things like that. That's where Kubernetes would shine, because you could create as many deployments of these, basic, like different containers. So say there was 8 containers in here, so you could have 5 deployments of, 8 containers. So that would be 40 containers, but you would be load balancing between those deployments and, health checks and all of those type of things.
With Kubernetes, do you use one of these Docker files, or do you provision them for the images individually? Like, does Kubernetes have its own file?
Yeah, Kubernetes has its own configuration files that you can read.
Okay.
There's the kubectl commands that's used to read in different configuration files, and the Kubernetes has the concept of pods, and pods are essentially one deployment, and in that pod you can have as many containers as you want, and so you can load balance between the pods, and each pod can have a group of 1 or more containers. So that's the building. The basic block in Kubernetes is a pod, and a pod can have 1 or more containers, right? So each pod would have like its own kind of Docker Compose file. Do you get what I'm saying?
Yeah.
But it doesn't use a Docker Compose file because that's a different technology. It's a similar concept.
Cool.
Yeah.
Makes sense to me.
Yeah, there's a lot to Kubernetes. It's pretty crazy. There's a tremendous amount there. Yeah, so that was my presentations. The whole thing about containers and Docker's just one container technology. A lot of people don't understand. It's like GitHub. GitHub is only one out of many Git hosting websites, right? There's, people say GitHub, like GitHub, there's GitLab, there's so many other, there's, Azure DevOps, there's so many different other Git hosting platforms, and Docker is just one out of many container technologies. So don't think that Docker is the same as containers. Docker is one version of container technologies, and the main thing that Docker got right was the ease of use factor. It's so easy to do Docker container, Docker run. That was really the main innovation of Docker, is that they made it so easy for people to get started with containers. So
don't throw it in the trash outright. Give it a chance.
Yeah, if you don't like Docker Desktop, guess what? There's tons of other alternatives. Like you don't, go and look at Podman, go and look at all these other, alternatives to using container technologies. So containers are really a huge revolution in software deployment. So nowadays it's at the point where people will look at you weird if you're not deploying into containers, because
we have some stuff at my current role where migrations are a real big pain point. We have to reserve like who has the migration path next, and someone's floated this idea of like, if we just use Docker images, this would be a non-issue because our database and the state of the database could be in its own separate Docker image, and it would be fine. Like, you would just spin up a new Docker container and worry about it.
Yeah. Well, I will say that there is some overhead to containers, and running databases inside of containers is somewhat problematic at times. So, Yeah, like it's not always the solution, because there's overhead to any type of virtualized type system, especially databases. So that's one of the things that is not necessarily the best